Hey guys, I'm back. Um, so today we're going to be talking about my newest project, the LED cube. So you've seen this once before on my channel, I think. So anyway, I'll just give a brief overview of the LED cube and show it where it is right now. It's done. You could say it's done. It could still have more improvements, obviously, as any project can. But let's get started. It's a multiplexed cube. It's 3 by 3 by 3. Vertically connected like that are the anodes of the LED, so the positives. And those are directly connected via these white wires to the Arduino pins on this side. So that would, except for this last one, which is connected to the last Arduino pins. So that'd be 8 through analog something. It's this last pin here. And then these pins up to here skip the ground stuff, and then the first 3 pins on the top. And then the cathodes, which are connected in the layers, obviously, and go down to some 2N3904 transistors, which are set up as switchers, which are connected to these pins here, which I believe would be pins, digital pins 2, 3, and 4. So, and those are connected so that when you set it high, the transistor will connect it to ground. So all you have to do to turn this LED on is to set the top level to high and this column to high, and you're good. So if I try to turn these two on, these two will turn on as well. So the problem I have, the way I've solved this, is by no more than one LED is ever on at the same time. So when you're looking at the screen, when you're looking at the cube, maybe the refresh rate won't agree with my camera, but only one LED is ever on at a time. There's never multiple LEDs on. So that's pretty much the cube. It's running on an ATmega 328 16 megahertz Arduino, running the Due Millenove bootloader. It's got some power supply filtering here. I have a separate video on how to connect using one of these FTDI adapters connected to my camera strap. How to connect one of these FTDI adapters to program. That's what I've done here with this header. You just plug it in, and then you are ready to play. So, I haven't had this set up in the traditional LED cube sense. The traditional cube sense is that you will just make some cool animations. I haven't done that. I've actually programmed a video game on here with this switch. This is not a power switch. So, what I have programmed on here is 3-dimensional tic-tac-toe. I'm not sure, but this may be one of the first, if not the first, instances of a truly 3-dimensional video game. Not just things like the 3DS or something where it has a 3D, coating over the screen or something, makes it look like in 3D. This is actually in 3D. So maybe I may be the creator of the first 3D video game. If not, certainly it's one of the first. It's pretty cool. So since it's 3-dimensional tic-tac-toe, it's very challenging. It's a very challenging game. And it may be possible that the first player can rig the game to be won every time, just like you can in regular tic-tac-toe, although I'm not sure. So anyway, here are the buttons and the switch. The switch basically controls, it's 2 players as of now, and since these LEDs are one color red, you can only see one player at once. So the switch basically controls which player it's showing. Up, it's controlling the first player, down is showing the second player. This top button will move the LED, will move the position that you're going to set your new LED to vertical. The middle one will move it that way, and then this bottom one will move it this way. Okay? So, and this button says that you're finished with your turn. Right? So, if I flick it up, because first player, right, it's the first player's turn right now, because I just plugged it in, right? You see I'm hitting all the buttons, and nothing happens. So if you're on the wrong player's switch, right, if you're the first player, and you're on the second player's side of the switch, if the switch is the opposite position of the player who's going, then it's going to only show the LEDs that player has set, and you're not going to be able to do anything with controls. So if we switch to the first player, who I am, I'm going to hit the up button, and you'll see that the LEDs blink, right? So I'm setting it vertical. If I go one more than vertical, it's going to go bottom. So now I'm going to go towards my finger, right? And then you're going to see it's going to skip to the next row. It's going to skip there, right? So, and then this LED you see is going to move it back. So you see it's there. Now it's going to move back. Now it's going to move back. Now it's going to reset there, move back, and such. So I'm going to set the middle, and I'm going to hit done, right? So now since it's on the second player's turn, because I just finished, the switch is not the second player, it's the first player, it's showing where I just went, but it's, none of the buttons do anything. So if we switch to the second player, you'll see the second player can use a similar control manner. So he wants to go there, right? Now the second player is going there, so now none of the buttons will do anything because it's the first player's turn. So the first player is now going there. Perhaps I should turn the lights off for this thing. So that's on the first player, that's on the second player. And so the first player now, it starts where you just were. So let's take right there. And if you try to go where the other player's gone, it's just going to invalidate your move. Basically, it'll count your move as nothing. Like you did nothing in that move. Okay? So, that's the game. Really. So you can see that now we're on first player, we've done nothing. So the second player, hey, let's defend ourselves. So, oh no, now the first player is blocked, right? So, let's see what happens if we try to go in the same spot as the second player. Nothing, you see. Now it's the second player's turn. So it just counted like we did nothing. So, that is the game. It's not very complicated. It's 1,000 some lines of program. Anyway, so far the issues with it are it can't tell if you've won, so that's going to require many lines, at least 1,000 lines or something, because in this cube there are many different possible combinations, something like a 72 or something, or around that number, maybe 76, because you have all three dimensions, right? So you have three tic-tac-toe boards in each dimension, so that's 9 tic-tac-toe boards. Each have 8, so that's 72, plus you have the 4 ones that cross through every dimension, so that you have 76 different possible combinations. And that's going to require a lot of if statements to do. So, anyways, so for all of you that want to make something similar, you can see how I did it. The code will be on my website, quicknuclearscience.webs.com, and it's going to be in the files section. So check that out. I guess I'll talk a little about the code now, just for a basic overview of things. For a basic block diagram of what it does, it basically there's these one variable for each LED, like I said, and if it's 1, then it's the first player. If it's 2, then it's the second player, and if it's 0, then there's nobody's gone on that LED. It starts off by seeing if it's the first player's turn. If it is the first player's turn, it checks if you set the switch to display first player. If you have it, displays all the LEDs that are equal to 1, and then makes the button basically flash the LED that you've selected, but not actually, make it permanent. You press the button, and it makes it permanent, and then it does the same thing for the second player. Now, if you've switched the switch, if you're the first player, say, and you switch the switch to display the second player, it's just going to display the second player, and none of the buttons will do anything. And if we hit end, it's going to be 1,292 lines of code, but without this blank space, it's 1,245. So anyway, this code will be on my website, but I hope that's, a bit more clear to you guys. Sorry for the bad, camera. This might not be good to look at, but we'll see. Thanks for watching.